Hello everyone, let's talk about this Microsoft Fabric Lakehouse. So without further ado, let's go and jump right into the content. We'll be talking about what is a lakehouse. This is a theoretical level 100 tutorial. So the key features, core functionality, and how to create Fabric and the Fabric Lakehouse best practices. And I'll go jump into a simple demo. So a lake house is pretty much like a real lake house. As you can see in the background, it's a lake. That's a lake, which is your data, and then you have a house, which provides you the structure, comfort, and accessibility to the water. And a public lake house sits on top of a data lake and provides structure, governance, and easy access to the data. So, definition in Microsoft Fabric, Lakehouse is a data repository for storing, managing, and analyzing both structured and unstructured data in one place. The core idea is that it merges the scalability of a data lake and with the organization and performance of a data warehouse, which is it has a structure, it's query ready. Capabilities, that's automatic table discovery and registration to the tools that you need to use it. And then you have SQL analytic endpoint for query. It has integration with Power BI, Spark, and Data Factory. It's built on OneLake's Microsoft Unified Storage layer. So the unified storage, so all data is stored in Microsoft OneLake, a single logical data lake for entire organization. It eliminates data silos by centralizing structured and semi-structured and unstructured data. It uses Delta Lake table, so it's Spark K plus the transaction log for reliability, and then you have ACID transaction and schema enforcement. It ensures interoperability with the Spark, SQL, and other engines. It provides SQL analytic endpoint for querying structured data and Apache Spark for big data processing, machine learning, and advanced transformation. So instead of having one querying tools, you have now Apache Spark as part of it. So you have a dual query. So automatic table discovery, so once you create a table in the Lakehouse, they are automatically registered into the Fabric catalog. They enable seamless integration with Power BI and Fabric Experience. For direct BI integration, Power BI can connect directly to Lakehouse table for real-time reporting and dashboard, and then there's no need for complex ETL pipelines into separate warehouse. Additionally, you can create a shortcut in the Lakehouse to other data sources, and you really don't need an ETL. You can direct query from Lakehouse. So dual query, as I mentioned, we have two querying tools. We have the Apache Spark for large-scale data engineering, complex transformation, and data science workload using language like PySpark, Scala, and Spark SQL. This is the primary engine for writing and transforming data into the Lakehouse. And then if you have the SQL investment, we have the SQL analytic endpoint, which automatically generated with every Lakehouse, and this is a read-only T-SQL interface over Delta Lake. In the Lakehouse, it allows analysts to use familiar SQL tools and T-SQL syntax like creating views and function for querying, modeling, and reporting. So as the data is stored in the Lakehouse, it is stored in a Parquet file inside the lake, and Delta Lake adds a transaction log that tracks changes, schema updates, and version. This makes structured data queryable with SQL engines like Spark, Synapse, Databricks, and Fabric, while being scalable like a lake. So benefits: ACID guarantee prevent corruption during concurrent writes. For performance, you have optimized read and write with indexing and caching. And then you can mix structured for delta tables and semi-unstructured data in the same lakehouse. Time travel, it provides you the query to query historical version of your data for audits and debugging. For best practices, you need to treat data as a product and then curate dataset with clear definition, schema, and lifecycle. Ensure semantic consistency across layers so business user can trust the data, and then document the metadata and lineage to make data discoverable and reusable. Eliminate silos, so store structured, semi-structured, and unstructured in a single lake house. Avoid unnecessary ETL hubs. Use Delta Lake or similar format to unify storage, keep curated and consumption layer in the same environment for efficiency. For governance and security, adapt organization-wide governance for access control, auditing, and compliance. Use your RBAC or role-based access, and fine-grain the permission. Monitor data usage and enforce policy for sensitive information. Yeah, we still need to enable self-service analytics, so it provides SQL-friendly interface so analysts can query without deep engineering knowledge, build semantic layer and curated views for BI and ML teams, encourage democratization of data by lowering the barriers to exploration. And then we have to optimize for scalability and performance. You use the Delta Lake features like Z-ordering, data skip, and caching. You need to partition data wisely. This is for you to minimize your cost, because the storage is cheap, but if you use a lot of query and you use a lot of GPU, that's going to be more costly than your storage. Continuously monitor workloads and tune storage and compute balance. So this is for your cost effectiveness, right? And then it is encouraged that you support AI and ML workload. So design pipelines that serve both BI dashboard and ML training dataset. And then you keep historical version of data for reproducibility, integrate with ML frameworks directly from the warehouse. Trade-off, over-engineering, so too many layers of transformation can slow agility. For governance gap, without strong policy, self-service can lead to inconsistent metrics. Cost creep, again, if you don't index or you don't make use of your GPU wisely, and without a strong policy, the storage is cheap, but compute for queries and ML can spike cost. Skills mismatch. So right now this is a really very new technology, and we have very few professionals who are using public right now, so you need to train your resources. And then we'll jump right into the demo. So right now I'm here in the public portal, and I already created that my lakehouse. So basically you need to go to your workspace. So we know what a workspace is, so create a workspace, and then inside the workspace you can create your lakehouse there. Right, I already created lakehouse here, but you can create new item, and then just go ahead and create lakehouse, and just any object in the cloud or in public, you just click lakehouse, put a name on it, and then that's this is the you can choose which it's already choose the location for my workspace. So it's a lakehouse 2, for example, and then just click create. We're not going to do that because we already have a lakehouse, and this is really a very short demo. Yeah, why not? Let's just create it. We don't have a complex demo, so might as well just create the lakehouse. Okay, lakehouse 2, and then that's the workspace. and then just like that, and then we have the lake house. And then you can manage security here, so you can give permission to who and who cannot view your lake house. And then you have data agent. You can create notebooks from here. You can create semantic model, get data, so you can upload files, and yeah. So basically, if you are into the data engineering, Lakehouse is a combination of your S3 in Amazon or blob storage in Azure, and you can upload your files here, right? You can upload files, and you can just browse. So you can store non-structured data. Let's say I want to put a video, and let's say I want to create my video storage here, so I can just basically upload that, and I can put Excel, I can put CSV, or whatever files I want to store, right? And or probably in my case, I'm gonna put my training videos there, and I create a video catalog for my students, and this is like your S3 or the blob storage. You can store anything here, upload anything, any files that you want. And this guy here is like the Azure table, or pretty much like your table in any RDS. So you can create a table here like okay, for the tables, let's just right click and create new table. Very bad. It doesn't have a create table where you have a GUI, right? Instead, anyway, these are, it's gonna tell you this one on top. It tells you where you are, so we're in the lake house. This is the workspace, so some sort of navigation, just in case you're lost, right? So that's a bit of a tip. For us to be able to create a table, and we don't have the GUI to go ahead and create that. What we can do is create a notebook. Okay, so I'm gonna create a new notebook here, and there we go. So we are here in our navigation, we are in the lake house, and we have in the notebook. And here in the notebook, we can choose programming language that we want to use. So I'm gonna use, we have T-SQL Analytics, we have Python, I'm gonna use the Spark SQL. I'm gonna, okay, that's where our lakehouse is, and we don't have a table right there right now. We're going to create a new sales data table, right, using a familiar SQL syntax, and go ahead and run it just like another notebook. And okay, 15 seconds. Session is ready in 7 seconds. Gonna refresh this, and we're supposed to see our table here. Okay, SparkJobs has succeeded, and we refresh this. We now have the sales data table. So again, these are your structured table. This is, you have the schema or a structure here in your files. You can basically upload any files that you need. And yep, that's pretty much into it. Let's just do a recap and let's see. Yeah. Okay, so the lake house is just pretty much like a lake, which is your data, and we have a house that provides you the comport and structure to query the data, governance and everything, and the tools. And there's unified storage for your structured and unstructured data, and you can use SQL, and you have SQL and Spark endpoint, and yeah, it automatically integrates to Power BI and the rest of the tools that's on Fabric. And yeah, we can use ML workload, and for governance we need to use the RBAC, and for scalability and performance it can handle petabytes of data with distributed compute. Anyway, Fabric is a software as a service, so you don't have to worry about the compute. Just scale it, it will automatically scale for you. Then optimize query performance through caching and indexing. That's for your best practices. And then we have both Apache Spark and SQL endpoints in one place, and yeah, it's stored on Delta Lake, and it's stored in the Parquet. And that's all for now, and thank you for watching. Yep. Please watch more videos that are going to that we're going to create in the future. That's all, and thank you very much for watching this tutorial.